In the previous video, we discussed whether it is still relevant to learn programming in 2026. The short answer was yes.
Oh, yeah, baby!
We also decided to start a C programming tutorial on this channel. Before writing our first C program, we need to set up a proper development environment that's usually referred to as an IDE. IDE stands for Integrated Development Environment. An IDE is a software application that provides everything needed to write and run programs in one place. This usually includes a code editor, a compiler, and debugging tools. Instead of using separate tools manually, an IDE integrates them into a single interface.
Come on. Let's go to you. I'm the best.
For the C programming language, there are several IDEs available. For learning C, any of these can work, but what matters is understanding the concepts. So, understanding the concepts. Let's do that now. Earlier, we casually mentioned a few terms, right? This usually includes a code editor, a compiler, and debugging tools. Let's slow down a little and understand what each of these actually means. A code editor is simply the place where you write your code, nothing more. You can even write C code in a simple text editor like Notepad, but using a dedicated code editor provided by an IDE makes the process much easier. It highlights keywords, formats your code properly, and makes it easier to read, navigate, and write. Modern code editors also offer features like IntelliSense, which suggests code as you type and helps reduce simple mistakes. However, by itself, a code editor cannot run your program. It's just where the code is written. Now let's talk about compilers. A compiler is basically a fancy word for a translator. What does a translator do? It converts something written or spoken in one language into another, right? For example, English to German. A compiler's job is also very similar, but instead of translating between human languages, it translates for the machine. It takes the code we write in languages like C or Python and converts it into machine language. And machine language is not English, not Hindi, not German, and it's certainly not C, Python, or Java. Machines understand only one thing: binary instructions which are made of zeros and ones. At the hardware level, these zeros and ones correspond to physical states inside the processor. A processor is built using billions of tiny electronic switches called transistors, each of which can be either on or off. By interpreting these two stable states as 1 and 0, and combining many of them together, the hardware performs logic, calculations, and decision-making, and that is the only language the machine understands. So when we write C code, the compiler's job is to translate that human-readable code into a form the processor can actually execute. Now you might be thinking, if machines understand only zeros and ones, how does Siri respond perfectly to my stupid questions?
Siri, how do I perform self-circumcision?
How does ChatGPT understand natural language and give responses that are brilliant, contextual, and so human? Here's the thing. Systems like Siri or ChatGPT do not understand language the way humans do. They convert speech or text into signals, signals into numbers, and numbers into patterns. Those patterns are processed by models trained on massive amounts of data, and the output is generated based on probabilities, not understanding. Even then, everything eventually runs on machine instructions. There is always compiled code underneath written in languages much closer to the hardware. These AI systems act as very high-level translators, but the foundation is still the same. So a compiler is simply a software program, a tool, that translates our source code written in human understandable language into machine language. And that's all you really need to understand about compilers for now. You don't need to worry about how a compiler is built internally. You don't need to understand every optimization it performs. You just need to know what it does and why it exists. Now I'll show you how to install a C compiler on your system. This process is specifically for Windows. If you're using Mac OS or Linux, the setup is much simpler, and we'll talk about that later. But wait, how do you know that you don't have a C compiler already installed on your system? To check that, open the command prompt and type the following command. If GCC is not recognized as an internal or external command, then you probably don't have it. Also, you would know if you previously installed, right? Anyway, no worries. I'll now show you step-by-step how to install one, configure it, and compile your first C program. Just follow my lead. Open your favorite browser and go to the following link. We are not yet installing the compiler. What we are installing now is Minimalist GNU for Windows. It's basically an environment that lets us install and manage development tools on Windows, including the GCC compiler. Scroll down and click here to download the installer. Save the file to your preferred location. Once the file is downloaded, double-click on it to start the installation process. It would then ask you to make some choices. Leaving them at the default and clicking Next when prompted would be a wise choice. It would take some time for the installation to finish. Once the installation is complete, a terminal window will launch. We now need to install the GCC compiler using this command. Copy and paste it into the terminal. And enter. Proceed with installation? Yep. And here we go again.
So there's this suitcase.
I don't care.
Yeah.
Once the compiler is installed, close the terminal window. Installing the C compiler alone does not make it usable. The compiler's path must be added to the system's environment variables, so the system knows where to find it. To do that, open File Explorer and locate the folder named MSY64. Open it, and then open another folder called UCRT64. Inside that, open the bin folder. If you can see the files named GCC and G++, you are good to go. Now, copy the location of this bin folder. Next, open the Start menu and start typing Environment. Click on Edit the System Environment Variables. From the pop-up window, click the Environment Variables button. Now double-click on Path. We need to add the C compiler's path here. Once that is done, close all the pop-up windows. Now open a new terminal and type gcc version. If you see the compiler version, it means the compiler has been detected by the system. What does this mean? It means that you can now write C code on your system and translate it into machine language using the C compiler we just installed. This allows your machine to understand your instructions and execute them. Now let's quickly test our C compiler. First, we'll create a new folder to organize all the C programs we'll be writing in this tutorial in one place. I am going to name it as E_programs. Next, we'll write our first C program in Notepad. Through this program, we will print a simple message on the screen. If you're wondering what things like hash include stdio.h or the main function mean, don't worry about it for now. We'll learn everything step by step as the course progresses. All right, what should we print? Let's print this. Hello, I would like to order a large pizza. Thanks. Now save this file. Make sure to save it with a .c extension. For example, firstcprogram.c. Also use only letters and numbers in the file name, and avoid spaces. These are common conventions and help avoid problems later. After saving the file, open the command prompt again. Change the current directory to the C programs folder using the cd command. Now, compile the source code using this command. gcc first C program .c-o pizza.exe. You can choose any name for the executable file. Here I'm naming it as pizza.exe. As soon as you run this command, you'll notice that a new executable file is created. This executable file contains machine-level code generated from our C program. To run the program, simply type pizza.exe. Press Enter, and you should see the message printed on the screen. Voila! We have successfully compiled and executed our first C program using the command prompt. Now, one important thing to remember. Once we start using an IDE, you won't need to go through all these steps manually. An IDE can compile, run, and even debug your code with just a click. I showed you this longer process so that you can clearly understand what compilation actually